Hey guys, Mr. Milton here. Today we're going to talk about solving quadratics by graphing. At the end of this video you should know where to find the solutions to a quadratic from a graph, and you should be able to solve a quadratic by graphing. Okay, a quadratic has the general form y equals ax squared plus bx plus c. Okay, to graph, we found the axis of symmetry. I'll just say AOS here. Of the parabola, and then we found the vertex. Okay, so that's just reminding us how we graphed. Spent the last two lessons on that. From this lesson on, we'll be using the following form for a quadratic, and that will be 0 equals ax squared plus bx plus c. Okay, and this change indicates that we are solving the quadratic. So whenever you see 0 equals ax squared plus bx plus c, you'll know that we're solving it, not just graphing it. Okay, on a graph, y equals 0 anywhere on the x-axis. Therefore, when we are solving a quadratic, we are looking for the x-intercepts. Okay, or any place on the graph where the graph crosses the x-axis. Okay, there are four terms that are synonymous or synonyms for solving quadratics. You might see x-intercepts today. You might get them called as solutions, obviously. You might get them called roots. And you might see them called zeros. Okay, all these mean the same thing. Different methods usually call them different things, but they're the same. Okay, so let's jump right into it, solving this function. Okay, remember our process. We're going to find the axis of symmetry. After we find the axis of symmetry, we're going to find the vertex. From there, we're going to make a table. And then we're going to graph. Alright, so those are our same steps as if we were just graphing. So for this solving, we're at one step, which, well, I'll just say solve, which is really just identifying the points that are important to us. So we go through, find the axis of symmetry. Remember that's opposite b over 2a. For this, b is negative 6, so opposite b is positive 6. Over 2 times a is 1, so 6 over 2, which gives us 3. So our axis of symmetry is at x equals 3. Remember, that means that will be in the middle of our graph, or of our table, and our graph. Okay. From there, we will find the vertex. So this is step 1. We'll find the vertex by plugging 3 into our function. So 3 squared minus 6 times 3 plus 8. That's 9 minus 18, which is negative 9. Negative 9 plus 8, which is negative 1. Okay, so our vertex is at 3, negative 1. 1, 2, 3, negative 1. Okay, that's the middle of our graph. Now what I'll do, since I have my axis of symmetry, I'll dot that in here too. Okay, from here, what I will do is I will fill in the other, or one side of the table. So I'm going to plug in 2 and 1. Seem like easy enough numbers to plug in. 2 squared, which would be, so here's the function, 4 minus 12, which is negative 8. Negative 8 plus 8 is 0. Okay, and then I'm going to plug in negative 1 squared. Or sorry, not negative 1, just 1 squared. Okay, so 1 squared, 1 minus 6 is negative 5, plus 8 is positive 3. Okay, and so I have the spot at 2, 0. I have a spot at 1, 3, 1, 2, 3. Okay, so these 3 points here. So what I can do, I can see that there should be some symmetry here because I have my axis of symmetry. Okay, so I can do that symmetry visually. So if there's 1, 2 to the left, there's one going to be 2 to the right. I could also see that symmetry on our table numerically. There's 1 less was at 0, 1 more will be at 0, 2 less was at 3, so 2 more will be at 3. Okay, either way, in both ways, we see this is our graph. So this is all a review from our last 2 sections, putting our last 2 sections together, using it here. All right, now this is where we get to our new part, solving, because we have not solved it yet. Well, we've solved it, but we haven't identified the solutions yet. Remember that the solutions happen when y is 0, because notice that what we did in our equations, we changed our form from y equals ax squared plus bx plus c to 0 equals ax squared plus bx plus c. So what we did was we substituted y for 0. So when y is 0, that's where our solutions happen. Y is 0 on the x-axis, that means here and here. Our solutions are the x values that make the equation true, make y 0. Okay, so after graphing, we see that the parabola crosses the x-axis twice. That means that this equation has 2 solutions. The solutions are 2 and 4. Those are the 2 x values that make y 0. Okay. If you look at the table you created to graph this quadratic, look at the y values corresponding to these solutions. What do you notice? They both equal 0. Okay, again, that's kind of what we're going into and talking about for most of this page. All right, so we got a couple more problems to go through to make sure that we understand what's happening, and then from there we'll be done. Okay, so we have negative x squared plus 4x minus 4. We have to solve this by graphing. So we'll go through, do the same thing, find the axis of symmetry opposite b over 2a. Okay, and simplify that, that gives us 2. So our axis of symmetry is 2, first step. Our second step, we need to find the vertex. Okay. And so our vertex, we can find that by plugging 2 into our function. So negative 2 squared plus 4 times 2 minus 4. So 2 squared is 4. Negative of that is negative 4. Okay. Plus 8 minus 4. So that gives us 0. So our vertex is at 2, 0. Now I'm going to make my table. That is the middle of my table. Okay, I'm going to plug in a couple points. Okay, this one's actually pretty simple, but I'll show it all out anyway. It's just regular 3. Alright, so I plug in 1 squared, negative 1, plus 4, minus 4. Okay, so that gives me negative 1. I plug in 0 squared plus 0 minus 4 gives us negative 4. Alright, so as I see this here, we have 3, negative 1, and we have 4, negative 3, 4, negative 4. Okay, we can do the whole axis of symmetry thing. I filled in the entire table. You can do it either way. You'll see that it comes out to be the same. And now, how many solutions do we have here? Notice that our solutions, or remember, sorry, that our solutions happen on the x-axis. So this only has 1 point on the x-axis, 1 x-intercept. So how many solutions do we have? 1. What is the solution? Well, this is the solution when x equals 2. When x equals 2, y is 0. That's our solution. All right, let's do it again with this next one. Axis of symmetry. Remember, we do that opposite b, so negative 2 over 2a, so 2, so negative 2 over 2 is negative 1. X equals negative 1 is our axis of symmetry. Okay, I can put that here. Okay, we know our vertex has to be on the axis of symmetry, so we plug that our negative 1 value in. Okay, so I plug negative 1 in, negative 1 squared plus, excuse me. Okay, plug that all in, that's 1 minus 2 plus 3. So it's negative 1 plus 3, which is going to be 2. So our solutions are not our solution. Our vertex is at negative 1, 2. That is the center of our table. Negative 1, 2. I'm going to use 0 and 1 because those seem like pretty easy numbers to plug in and figure out what is happening. So when you plug 0 in, 0 plus 0 plus 3. Okay, so 0, 3. And then I plug in 1, 1 plus 2 is 3 plus 3 is 6. Okay, 3, 4, 5, 6. All right. I go ahead and count over. Okay, and here's my graph. I can complete the table just to make sure we have that down. Negative 2, negative 3, 3, 6. All right, how many solutions do we have here? Well, remember our solutions happen on the x-axis, and so any x-intercepts are our solutions. We see that there are no x-intercepts, so we have no solutions, which is possible for a quadratic, obviously, after seeing this. Okay, remember our solutions happen when our function equals 0, and if it can't equal 0, there's no solution. All right, so that's graphing and solving by graphing. You get to do the same process that we've been practicing for just about a week now. Okay, moving on from there, we're going to talk about the disadvantages of solving by graphing. Okay, so obviously, well, not obviously, the disadvantages for solving by graphing are the disadvantages for graphing altogether. Graphing takes a lot of precision, first of all, to do it anyway, but with fractional and decimal answer possibilities, that's going to be an issue for us to see, especially if we're graphing by hand and not using some program. But let's see it in practice. Okay, so let's graph this. Okay, going through the same process, axis of symmetry, do opposite b over 2a, so negative 8 over 2 times negative 2 or negative 4, which gives us 2. So our axis of symmetry is at x equals 2. Axis of symmetry is x equals 2. Okay, so now we need to find our vertex. Okay, we find our vertex by plugging in 2 into our function. Negative 2 times 2 squared plus 8 times 2 minus 5. So that's 4, negative 8, plus 16, minus 5. So that gives us 3. So our vertex is at 2, 3. Okay, from there I'm going to make my table, making sure that 2, 3 is in the middle. I'm going to choose some numbers around here. I'm going to pick 0 or 1 and 0 because those are small numbers that seem easy enough to plug in. So I plug in 0, 0 plus 0 minus 5, that gives me negative 5. I plug in 1, that's negative 2 plus 8, which is negative 2 plus 8, which is 6, minus 5, which is 1. All right. Okay. Now I can plot those points. I'm at 0, negative 5, 1, 2, 3, 4, 5. I'm at 1, 1, 1, 1. I'm at 2, 3, 2, 1, 2, 3. Okay, and then because this is the axis of symmetry, I know that the points are reflected across that line. So 1, 2, 1, 2. All right, all that's done. All right, now if I was asked to just circle where the solutions were, or I could circle where the solutions are because I know that my solutions are on the x-axis. This is where my solutions lie. And so I can see that, hey, there should be 2 solutions. Now, when asked what are the solutions, I can't tell you specifically. I'm not looking at this graph. I did my best, but like I know it's here and here. And I can tell you that the numbers are between 0 and 1 and 4 and 3, but not much more than that because I can't tell accurately based off the graph. Okay, so this example shows 2 major disadvantages. By solving by graphing, it is time consuming because it did take a while, and you're not able to find the exact solution or the solution In some problems, because the parabola doesn't cross the x-axis at, I'll just say neat. Okay, I like that word. At neat points. Okay, or exact points. Let's say that. Okay, the answer doesn't have to be. Sorry, I'm off the screen. The answer doesn't have to be 2 or 1. You guys know that just from the math that we've done, even just solving equations. We've had fractional answers and radical answers. The answer can be those answers, okay? And so it's hard for us to see those if we're just graphing. So what this does tell us is that it necessitates that we know different ways to solve quadratics, and we'll be spending the next couple weeks solving quadratics in different ways. Okay, and this, by the end of this will be your least favorite way, because you'll see how long it takes to solve a quadratic when there are different ways to do it. All right, but get good at this, practice this, get graphing quadratics down. All right, see you.